The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thanks for joining us this morning to look at some of the ways and tips and tricks that IT managers can use to ameliorate their Office 365 deployment, looking at addressing some of the typical challenges in deploying Office 365 securely and with maximum availability and performance. I'm delighted to be joined today by Andy Kennedy, who's a Senior Security Engineer at Zscaler, who have developed a purely cloud-first approach to securing and to deploying Office 365, supporting the web security for Office 365, and that's something we'll be sharing with you today. And so a bit of an agenda for today. We'll cover a bit of housekeeping at the start, a very short Bytes introduction. Many of you do know us already, so I will keep it brief. I'll introduce Andy Kennedy, who will be taking you through some of the 6 key challenges in deploying Office 365 and how Zscaler's approach to Office 365 deployment and support can aid in circumventing those core challenges. And there'll be a brief demonstration, and then we'll end with an interactive Q&A. So a little bit of housekeeping, first of all. Attendee lines will be on mute throughout the presentation. However, there will be an interactive Q&A at the end, so please do take the time to post your questions for that Q&A via the chat or the questions box, and I will pose them to Andy at the end of the session. We will keep discussions throughout the webinar to solutions and demonstrations, technical discussions. We won't be discussing commercials or financials on this session. Of course, we are happy to discuss them after the session with your Bytes account manager. And lastly, we will have a recording available for the session so that you can share the insight with your teams and also review that at your leisure as well. And then just a final quick reminder, we do with all of our webinars have a short feedback survey at the end, so please do take time to fill that in so we understand how the session has met your expectations and how we can improve future webinars. So, very briefly, who are Bytes? So we are a security specialist reseller within the Bytes technology group. We have been focusing solely on networking and areas of security for the last 16 years. However, we have, since 2011, we've been part of the multi-billion Ballard Electronics group, and what that means that we marry the specialism and personal approach you'd expect from the smallest independent reseller with the resources and reach of a large global group to support our customers. We pride ourselves on the consultancy and the expertise that we provide, the technical expertise we provide. We have a team of fully accredited third-line engineers who support all of our products, and we also offer a full consultancy suite for the products that we offer. That enables us to share top-tier vendor statuses with the world's leading global technology partners, which enables us to deliver commercial value in addition to that technical expertise. So where do we work across? So we work across network security, data, authentication, and predominantly mobility and cloud security, which is a key factor that we're exploring with customers at the moment and what we're talking to you around today. So within those sections of security, some of the things that you can expect to receive from Bytes are technology delivery, influence and maintenance. We offer direct escalation engineering support for our technologies, a variety of security strategy development, resources, project scoping, planning and delivery, and really providing the expertise that you would like to have in-house from your reseller partner, so that with a small IT team you can achieve the most from the technologies that you're investing in. So why are we talking to businesses around improving and adding to Office 365 as a product? So firstly, Office 365 is growing cloud service from Microsoft. It's Microsoft's fastest selling cloud product, and it's being adopted. What we have seen from customers and businesses we're talking to is they are facing genuine pain points that are limiting the success of its adoption and limiting how much they can actually achieve with Office 365 in terms of their business objectives. Many businesses are looking to adopt the cloud-first strategy. So they're looking for complementary technologies for Office 365 that are cloud-based to ensure that they are working in the maximum possible cost-efficient way around their cloud security as well as their cloud infrastructure products. User adoption of Office 365 really is a critical success factor. There are cloud-first approaches, such as the one that we'll talk to you about from Zscaler, which can defeat many of the security challenges, the deployment challenges that you may be facing around Office 365. So that's why we're talking to businesses right now around this. So with that in mind, all it remains for me to do is to introduce Andy Kennedy and Zscaler. Andy's a security engineer at Zscaler, who's been involved with various different companies in designing and augmenting their Office 365 and looking at their cloud-based web security. Zscaler have really taken massive steps in the market to position themselves as a security as a service specialist. So businesses that are looking for the best cloud-based web security that's purely cloud and genuine cloud-based are working with Zscaler at the moment. And they have a global reach. They protect more than 15 million users and are working with more than 5,000 organizations. So are a really experienced company in looking at how businesses can augment and perfect their Office 365 deployment. So with that in mind, I'm just going to hand over to Andy, who'll take you through our secrets to Office 365 deployment success. You'll briefly go to the holding screen and then you should see and hear Andy. Fine. Over to Andy.
Thank you very much. So if you just bear with us 1 second. So good morning, everyone. I'd like to extend my welcome to today's webinar, and of course, thank you to Shona and everyone at the Bytes team for inviting us.
Andy,
yep.
sorry to interrupt. We can't see your slides. We're currently just seeing the holding screen. You'll need to share your screen.
Can you confirm now that you can see them?
Yes, that's fine. I can see your presentation now. Thank you very much. I'm going to mute off. Yeah.
Lovely, thank you very much. And so I'd like to just say thank you to Shona and the Bytes team for inviting us back to offer the opportunity to present on another webinar. And today's title is 6 Secrets to a Successful Office 365 Deployment. So actually, the title itself maybe belies the actual true nature of today's discussion, which is really just to share some of the lessons that we at Zscaler have learned through a number of collaborative projects with our customers who are also Microsoft Office 365 customers and who are using Zscaler as a way to connect to the Microsoft Cloud. And of course, that wouldn't be that catchy a title, so hence 6 Secrets to a Successful Office 365 Deployment is what we're going to do. But really, it's around sharing those lessons that have been learned so they are no longer a secret. So in terms of our audience today, I am aware that there may be a few people who are not familiar with what Zscaler does or what the problems are that we're trying to solve. So I wanted to just take this one slide just to share a little bit of information about what we do and what those problems are, and hopefully that will set the context for the main part of today's topic. So if I was to try and summarize what Zscaler does, we're effectively a cloud-native network and security platform. And really, what does that mean? Well, cloud-native is really emphasized because we were actually, from our inception, intended to be operated and run as a cloud service. So from that perspective, our software stack, our operations model, our processes, our procedures, our people have all been built around operating and running this cloud platform that enables our customers to connect efficiently to software as a service platforms, and that's going to be our focus today, but also to secure their interaction with the internet. And if we think about the problems that we're trying to solve then at Zscaler, then they really break into 4 main areas, and those are shown on the screen. And when we work with our customers, what we're trying to do is help them embrace a network architecture that will allow them to basically address all 4 areas. And I'll walk you through each one in turn so that you're comfortable and familiar with what we do in that space. So principally, it's around, in our origins, were around securing users and devices as they interacted with the open internet. And particularly there, it was around security. It was around dealing with the challenges around acceptable use policy management. It was around advanced threat protection. It was around providing visibility and monitoring of what people do on the internet. It was also around helping people with things like data loss prevention, etc. Now, in our last webinar that we did with Bytes, we actually spent quite a bit of time covering this topic. So if you are interested, please feel free to refer back to that on the Bytes channel on YouTube. Today, though, we're going to focus on how we're also helping our customers enable the adoption of software as a service. And of course, we're going to focus specifically on Office 365, which is the most widely adopted enterprise bare metal, they might be virtualized workloads, they might be containerized, or they might be on their journey to the way to the public cloud. And there we're actually helping our customers provide secure remote connectivity to those applications, but we're doing so in a way that negates the need to have any virtual private networking technology or infrastructure in place. So maybe we'll come back in a later date to talk about how we do that, but today we're going to focus on how we enable our customers on their journey towards adoption of Office 365 as a software as a service platform. So maybe just to share a little bit then about where those lessons have actually been learned from. So we've been working with a large proportion of our customers. Today, as Shona mentions, we have somewhere in the region of about 5,000 plus customers that subscribe to the Zscaler platform. And within that 5,000 customer use base, we then have 50 million users, of which actually 700 of those customers, and in fact that number is growing every day, are actually consuming enterprise applications such as Office 365 through the Zscaler platform. And to give you an indication of scale that we're operating at, we deal with somewhere in the region of about 1,200 terabytes worth of traffic that is actually traversing the Zscaler platform on its way to Microsoft as part of the Office 365 suite. And indeed, some of our customers are continuing to push the envelope when it comes to the level of consumption. And to give you one example, one of our larger customers today consumes somewhere in the region of 46 terabytes worth of traffic each month from Microsoft across the Zscaler platform itself. So to give you an idea, I mean, many of the customers that we have that are consuming Office 365 are actually consuming that and are household names. People like Tesco, of course, Heinz and Philips, you will all be familiar with. Also large-scale organizations such as General Electric, as well as Kelly Services, you might have seen in the high street from a recruitment perspective. All of these organizations are using Zscaler as their preferred choice for accessing Microsoft Office 365 suite. So the question is, if we have those customers who are using Zscaler, the question is maybe why are they chosen to do so? And I wanted to share a few of those lessons with you about why they have done so. So if we think about the dilemma that's faced by any enterprise IT architect, when they're asked to run that project, which is we want to move from the on-premise Office suite, we want to move from the on-premise Exchange servers that we have, we want to move to Office 365 because we want the agility of adopting new capabilities and features, and we want to reduce the overhead and burden of having to operate and maintain that infrastructure. At that point, they have to look more holistically at the bigger picture about what they need to do with the network architecture to make this successful, because there are a number of hurdles and problems that can occur if you don't anticipate some of the challenges and some of the requirements that will be placed on the network in order to have a good user experience. And indeed, the point I would like to maybe emphasize is it's really about making sure that we do deliver that great user experience during today's conversation. So we have existing policy management. You might have different interface consoles, of course, for different devices and different appliances. But the issue is that whilst you might be able to have those appliances, they don't typically work very well with the Office 365 suite. And we'll come back to some of the reasons why they don't work very well with it, because if you listen to Microsoft's advice and guidance, one of the things they say is actually to avoid using many of those technologies, because actually a lot of the protocols and a lot of the way that the applications have been written do not work very well through those security platforms. So one of the first challenges you're going to face is how to manage the routing of that traffic in and out of your organization. The second thing is that you're then going to have to deal with some of the challenges around the increase in traffic, because if you have a larger organization that might be distributed, then you're going to have to backhaul all of that traffic to that central location in order to get it out to the internet. Now, that causes a couple of problems. One is that we typically see on average, and this is kind of anecdotal evidence through our analysis of our statistics on our platform, a general increase of around 40% when it comes to the bandwidth, the internet bandwidth that's consumed because of the adoption of Office 365 traffic. Now, it's not just around the bandwidth growth, and of course that has to be accommodated by those middleware boxes, but also you've got the latency that gets incurred, and we're going to come back to this point as well repeatedly in today's discussion, because if you're having to backhaul that traffic, then really you've got the latency to get that traffic back to the headquarters before it even starts its journey on the way to Microsoft. So for many organizations said actually that's not going to work very well, so maybe what we can look to do is to try and replicate what we have in headquarters at our remote locations. And typically what we see there are, I guess models whereby people might try to deploy some form of branch appliance. Now the challenge with the branch appliance is that of course now you're adding more components to your overall network architecture. You're having to operate, manage, maintain, run, all the other kind of consequences of doing so. But it also becomes quite costly in terms of time, and it becomes quite difficult to maintain at scale. And we'll come back to some of the challenges around the Microsoft Office suite, because if we think about things like tracking URL and IP address changes that happen on a monthly cadence, that actually pushes quite a burden onto the operations team to be able to operate and maintain that. And also when you begin to look at branch appliances, typically you find they're a subset of the capabilities you have at your headquarters. So whilst you might be consuming Office 365 traffic, you will also be probably consuming other internet traffic as well through those same links and through those same devices. And the issue then comes, how do you secure that traffic? Because actually you tend to find that because it's got a subset of features, you're actually reducing your security posture at those locations. And of course, we're not even talking yet about remote users or road warriors who might be working from home or otherwise. So is there a different way? And at Zscaler, we believe there is. So it's not just about doing it a little bit better. I mean, if you want to do it a little bit better, a lot of people just buy a bigger box. But rather it's taking a different approach. It's about a network transformation that will allow you to get the most optimal and efficient way of getting your traffic to the Microsoft Cloud, and doing so in a way that gives you the best possible user experience. And the idea here is that it should be able to do so, but reducing the burden of having to deploy appliances, having to deploy additional software, having to manage all of that infrastructure, but rather just making a simple forwarding decision to send the traffic via the Zscaler Cloud on its way to Microsoft can help you accomplish the goal of providing that great experience. Now, of course, you might say, well, of course, Andy's going to say that he works for Zscaler, but actually, if we listen to what Microsoft are saying, this actually comes from the Ignite conference that was held just last year. And actually, if you listen to what they say, they actually offer a number of different mechanisms and requirements for Office 365. They recommend that you should always take a direct internet connection for getting the best possible experience for Office 365. So this is their recommendation. Now, it's interesting because if you think about what we just mentioned there previously around the hub and spoke architecture, where maybe you had centralized proxies, then the first thing that Microsoft advises caution and care should be taken, because if we think about the user experience, we'll come back to this in a few moments, you might have a browser-based experience, you might have the native client experience. It's not just necessarily about web protocols, but it's about other ports and protocols too. And things like proxies don't handle them very well. There's then obviously the scaling consequences and implications. Things like SSL inspection doesn't work very well, and you have to track a lot of exceptions and exclusions, because otherwise you will break the protocols and break the applications. And then maybe there's a different view that says, well, actually, well, we agree with that point, but maybe, Microsoft offer an ExpressRoute, so why don't we just use that? That's surely got to be the best way. I mean, Microsoft offer it. Well, interestingly enough, Microsoft have actually changed their advice around ExpressRoute. And if we look at the history, ExpressRoute was initially thought of as a way of getting traffic to Microsoft in the quickest way, but actually what they began to discover was it was becoming very complex and unwieldy in terms of the network architecture that had to be put in place. And indeed today, as it stands, you need actually an exception from Microsoft to support it. And secondly, you need a network assessment. Microsoft's own numbers suggest that it's probably a 3 to 6 month project to be able to roll out ExpressRoute. And of course, what it does though is introduce this single point of access again. So you're back to the centralized locations. You still have to backhaul all your traffic over your MPLS infrastructure just to get it back so that it can go out through that ExpressRoute. So actually, Microsoft themselves have changed their guidance and advice, and they only recommend ExpressRoute in very specific scenarios. So the first scenario is where there is a regulated requirement that mandates a direct connection. Now, some of you may be in public sector today. If that's the case, there may be certain requirements that you face that might mandate that. However, for most of you, that will probably be not a requirement that you'll come up against. And the second thing is maybe where your network latency and your performance is so bad that actually Skype for Business is not going to provide a usable experience. Now, given we're in the UK and given we have a presence across the globe at Zscaler, one of the things we'll talk about today is how we can optimize that experience and make sure that we do deliver a great Skype for Business use case. So there again, that is done under a network optimization assessment by Microsoft, and only if that network optimization assessment proves that the performance is so bad because your carriers and everything else are unable to get that traffic to Microsoft, will they recommend ExpressRoute. So today it's becoming a rarer thing for ExpressRoute to be adopted. Indeed, as Microsoft say, they do not recommend it as your first choice, but rather you should use a direct local internet connection or breakout. And one of the reasons why that's the case is because actually, even if you did spend your money on buying ExpressRoute, even if you did backhaul all your traffic to your central location to get it to go across that link, then you would still require an internet connection anyway for services that aren't supported over that ExpressRoute. So from that perspective, that actually means that you still have to provide some form of security. You still need, obviously, all that protection that comes with that access. So again, from that perspective, that's the reason why it's not a recommended model or path. Now, we did briefly touch upon it, but I'd like to come back to it. Of course, a lot of this is predicated on you being on-premise. What happens when you're out on the roads? Well, you might be on a great internet connection. You might be able to get to an ISP that's paired directly with Microsoft. But then, of course, if you're using ExpressRoute and you're using VPN technologies that have been around for the last 25 years, then the problem is you've got to backhaul all that traffic back to your central headquarters just to pop back out and get to Microsoft over that ExpressRoute link. So again, that can result in a very poor user experience. And again, there's the cost and complexity of having to manage and deploy that technology. So how can we help improve the overall performance? And one of the lessons we have learned is moving to a local internet breakout model actually makes a lot of sense. And there are a number of reasons why that's the case. So the first one from a technical perspective is really around the fact that when you go to access any software as a service model, then clearly we're going to have to provide some form of name resolution to get to that infrastructure. But the second thing is that a lot of organizations, and particularly if we look at what Microsoft have done with their global network, Microsoft have built a huge content delivery networking capability across the globe. And we'll talk a little bit about that later, about where they exist and where Zscaler actually paired directly with them. But the point is that if we think about what's required, is that ultimately what Microsoft would like is for that traffic to get to their network as quickly as possible, and then to allow Microsoft to optimize the delivery of the content across their global content delivery network to get that content out to you in the most efficient and optimal way. Now, the point is that in order for them to do that, they actually depend a lot on localization and GeoIP of your actual users. But a lot of this is predicated on actually where the traffic comes from. So if we take a couple of examples, so on the left-hand side, we have a local internet breakout, which is basically making a local DNS lookup and therefore will resolve locally. Then your traffic would go out through the local ISP to Zscaler and on its journey on to Microsoft. And that way you've got that local internet breakout, you have the ability to have a great experience. However, if we take a different approach, which was to say, well, why don't we try and have a centralized location where we have ExpressRoute or we have a centralized internet breakout? The issue is that what you end up having is the name resolution, for example, will happen and occur actually in a remote location. And the problem is that ultimately what will happen is that Microsoft and other software as a service platforms will figure out that you're actually in the location where that name resolution was actually originated from. Now, the challenge with that is that even if you do have some form of local breakout, if you're doing that name resolution at a remote location in a centralized manner, the problem is that ultimately you will still have your traffic tromboning potentially across the continent or even between continents, which can again obviously introduces a lot of latency, a lot of overhead, and can ultimately result in a very poor experience. So the example here, it really is just to emphasize the fact that at Zscaler, one of the first things we did is we made sure that we can locally resolve all of the Microsoft traffic. So even if you're using an explicit proxy, using a proxy or a configuration file configuration, then of course at that point we will obviously do the name resolution on your behalf. That name resolution is actually occurring within the same data center as our point of presence. So we're not relying, for example, on Google's name resolvers or anything else. We're actually doing that locally. And indeed, we'll come back to maybe some of the performance measurements we've done in this space, but typically our name resolution will occur in less than 1 millisecond. To give you an example, we've worked with some customers where the name resolution times were actually taking upwards of 50 milliseconds or above. And of course, that has a direct consequence then on the performance, not only of the initial experience, but also, as we mentioned as well, there's the consequences of that traffic being misaligned when it comes to GUIP. So we talked a little bit about DNS and what happens, but of course, as we mentioned, the implications then of accessing the Office 365 suite, the key is to get that traffic as quickly as possible to Microsoft's front door network, and then let Microsoft deal with the optimization of that traffic across their CDN. So the big challenge is that if you try to route that traffic across, for example, an MPLS VPN, then you're already incurring latency before it even starts to traverse the internet, where there might be further latency concerns or delays. Now, to give you an example, if we think about what would occur, many people will say, well, I can just do a ping or a trace route to figure out what the latency is. But that's not a very good measure, actually, and indeed Microsoft do not recommend that as a good measure of your overall latency characteristics. But rather what Microsoft recommend is to use basically the TCP handshake timer to basically understand what the actual performance characteristics are. So to give you an idea, I mean, today, if you use Zscaler, and for a lot of our customers who consume our service, Zscaler actually, when we're paired directly with Microsoft, our router-to-router latency is in the region of around 1 millisecond. However, when we begin to look at our TCP handshakes, they normally complete within the region of about 10 to 20 milliseconds or lower. The benefit there is that has that's an end-to-end latency or performance metric that we can evaluate and assess, and that gives us the ability to give some confidence to our customers that indeed we can deliver a great end-user experience. However, if we begin to look at the metrics that Microsoft provide, I mean, they always recommend, for example, within a continent that's always less than 50 milliseconds or less than 100 milliseconds between the US and Europe. However, it's easy to breach those thresholds if, for example, you're having to backhaul that traffic, because, of course, whilst you might have an existing MPLS VPN infrastructure which you might be using to carry that traffic, there may be many different hops within that network that would occur. And, of course, when that traffic leaves your network across the internet, then of course there's more hops to occur. Each one of those hops is incurring latency. You've obviously got the physics involved too. Actually, your end-to-end latency can exceed some of those thresholds, which ultimately can result in a very poor user experience. And again, it's all about the user experience here. And ideally, the lower the latency, the better the experience will be. Particularly for many of the applications they might experience around things like Skype for Business, as well as SharePoint. So we talked a little bit about maybe, well, surely we could solve this problem by using appliances in the branch and providing some form of local internet breakout at that branch. Well, that has been an approach that, unfortunately hasn't been successful, and there's a couple of reasons why that's the case. Other than the costs and the complexity of having to manage that additional infrastructure, which is a very significant factor, there are a couple of other challenges, and one of the examples that I'll refer to was a lesson that we learned when we worked with a large global recruitment firm. Now, this large global recruitment firm actually had a distributed number of appliances they had in the field in their offices for connecting to the internet and allowing Office 365 through those appliances. But they ended up with somewhere in the region about 600 firewall rules on the rule base, just on each appliance, just for their Office 365 traffic. Forget the fact that you have other internet services that are coming in over that internet connection and over that appliance. And that was just a burden for them to manage. It was very, very complex. And of course, it was not static. It would be changing on a regular basis. I mean, to give you maybe an indication, we tracked somewhere in the region of about 300 different changes last year to the IPs and the URLs that are actually listed on the Microsoft RSS feed for Office 365. And if we think about all of those different changes that are occurring on a monthly basis, you have to keep up with those because, of course, if you miss one URL, you miss one IP address range, then effectively the applications can break. Now, of course, if you have change management windows, that becomes a real nightmare to manage. Now, the second point is really around, and we'll come back to this in a moment, is actually the scale implications. We referred to one earlier on, which was around that anecdotal evidence that suggests you have an increase of around 40% in the overall bandwidth through those devices. So instantly they have to accommodate that. But also there's a session table implication as well. And we'll come back to this in just the next slide, but before we do so, the one point I wanted to mention, and sometimes we lose this when we talk about Office 365, is that we're providing network connectivity to the Microsoft Cloud through the Zscaler platform. But if you're going to use the internet as a transport, then you also are likely to be consuming, the BBC, eBay, Netflix, maybe discussion forums on buying a car or something else. So you need the acceptable use policy controls, you need the other security mechanisms that need to be in place as well on that device. And the problem is that if you deploy a remote appliance, the challenge is, as we mentioned earlier, it's often a subset of the capabilities you find in the headquarters. A couple of examples, it's very unlikely that you will have sandboxing technology in a branch office. Normally that exists in the headquarters, but of course, does that mean that your end users then, their traffic will not have to be sent through a sandbox if it's potentially a suspect? Well, that reduces your security posture. So there's a number of questions there. Consequently, I mean, are you able to do things like SSL inspection on that internet traffic? Are you able to do things like data loss prevention on that internet traffic? So there's a whole bunch of questions then that raises. So ultimately what it does do is often lead to an inconsistent security posture. So that's the reason why I think branch appliances, and one of the reasons why Zscaler advocates a different way and a different architectural approach to solving that problem. But let's come back to this performance consequence then of Office 365, because I think we don't want to digress too much on the security piece. But the key point is that when we think about Office 365, you've got the different applications, and you may be using them through a browser, but more likely you will also be using them as the native applications on your device. Now, the thing is, when you start those applications, actually what happens is typically we see somewhere in the region of 12 to 20 connections being established out to the Microsoft Office Cloud. Now, the thing is that when you have those 10 to 12 connections per user, if you think about it, it doesn't take that many users in order to build up a very large session table. Indeed, Microsoft have actually been advocating for some time that you should only ever have around 2,000 users behind a single public IP address. And if you think about it, that single public IP address is probably what you're natting all your users behind. Now, that advice and guidance has changed a little bit, and there's actually calculators now that can help you calculate how many users you can have behind a single IP address. But the point is that you can actually exhaust quite quickly the session tables. And if you think about the protocol itself, you have 65,535 ports available, then actually it doesn't take that many users to be able to exhaust those. And of course, these are sessions that are actually long-lived persistent sessions. So as they are set up, they are maintained and kept open. Now, the challenge is that this means that whilst your branch appliances and even your headquarter appliances were designed for maybe web traffic, now suddenly we're adding a huge burden to those devices, and they actually may have consequences in terms of their ability to scale. Now, at Zscaler, we've actually addressed this problem actually in a couple of different ways. We actually build our own TCP IP stack. So in our data plane and our software that we run on our appliances that run in our data centers in the cloud, those devices actually have the ability to create pools of effectively ports. So you can have multiple instances of 65,535 ports. So actually on a single node within our data center, we can actually support somewhere in the region of about 8 million plus connections. And of course, we have many nodes, so therefore we can scale elastically and horizontally in our cloud to accommodate even the biggest customers. So from that perspective, it's a problem that we have had to go and solve, and we've done that again by the fact that we do develop our own software and our own frameworks within our own cloud platform, and we operate that in a way that it would be impossible to do in an appliance form. So we've talked a little bit about some of the challenges and problems that we've seen. So one of the things we want to do today is share a little bit about how do we actually address them and how do we deliver the best possible Office 365 user experience, which is really what we aim to do, and that's our key objective. And the second is, how do we make it easy for you to do so? Because you may have hosted Exchange today, you may be moving to Office 365, you may have Exchange Online, you may be looking to try and move away from a on-premise suite up into the cloud. So how do we remove some of those hurdles that might exist about providing access to that suite, but able to do it in a way that's securely done? And lastly, one of the big challenges is that people make these migrations and do this transformational change within their business to accommodate these collaboration suites and accommodate these enterprise applications. It's around providing the application kind of visibility and control. How do you make sure that, for instance, that we know how those applications are being used and how they're performing in the same context as we know, for example, if we're using the internet as a transport for those applications, how do we know that also applies and make sure that it's protected against, say, streaming media applications like YouTube and Netflix? So the first thing is that with Zscaler, the way that it works effectively is we advocate just forwarding your traffic through the Zscaler cloud, and we will help it on its road, on its journey to the Microsoft Office 365 network. So the key point here is that there's no hardware required, there's no software required, it is a cloud platform. So in effect, you subscribe to the service, and ultimately there's some simple changes that can be made on your infrastructure. Typically what we recommend is a simple overlay tunnel from an existing device that you have on your premise. It could be a GRE tunnel, it could be an IPsec tunnel, but that tunnel effectively terminates in a Zscaler data center close to your location. So the key point here is that from your location to the Zscaler data center point of presence, that latency should be very low because it will be local to your organization. Once it's at Zscaler, of course, then upstream, we then peer directly with Microsoft, and we'll show you our peering map with Microsoft. And we peer directly with them, and as I mentioned, our router-to-router latency is somewhere in the region of 1 millisecond. And we'll talk about some of the measurements we've done to provide some evidence to support that statement. As we mentioned, our scalability is accomplished through the fact that we have this unique architecture that exists within Zscaler. So not only do we build our own software, but we actually run, operate, and maintain a cloud platform that utilizes that software. And that's unique in the marketplace because most organizations, they either buy that software or they buy the software from someone else and run it, or alternatively, they create the software for somebody else to run. For us, we actually do both. And the key point here is that because we've done that and because we've learned the lessons through our work through the last few years about helping customers on this Office 365 journey, we've accommodated, as we mentioned, some of the challenges around things like port exhaustion, session table exhaustion. We've accommodated that and we'll fix those issues. We also, and we'll talk about it as well, have looked at the policy challenges. So one of the things we have is an automated object, effectively, that is in your policy that can effectively keep up to date with the changes that are occurring in the Microsoft Office 365 URL and IP address lists. That way it means it takes the burden from you to have to maintain and keep up to date with that information, and that's taken care of by Zscaler. We talked a little bit about the fact that you're combining your traffic because you're using the internet as a transport with the general surfing with the enterprise application traffic. And here really it's around making sure that we can deliver bandwidth controls. Now we're in a unique position at Zscaler because actually we sit at the other end of your internet pipe. Now the good thing about that is the fact that we can actually control what gets sent down to you, which is very hard to do otherwise because if you might imagine, you can't really control what gets sent from the internet to you. Normally your only point of control when it comes to quality of service is actually on the device, it's actually in your location. Now because Zscaler sits at the other end of the pipe, what we can do is we can manipulate the traffic that comes towards you. So for example, we can prioritize your Office 365 traffic over YouTube. Now the key point here is that we don't necessarily need to block people being able to watch YouTube videos, but what we can do is we can manipulate, for example, the window sizes that exist in the TCP segments. And the benefit there is that what allows us to do is take advantage of things like YouTube's adaptive streaming protocols, so that ultimately you might go from a high definition video down to a standard definition video under congestion conditions, but you're still getting access to the video, but what you're ultimately doing is protecting that Office 365 traffic that's also running on the same pipe. And that's really important because it gives you that great end user experience as we mentioned. Now, the fact that we can deploy with a simple configuration file on the endpoints means that there is actually no VPN required to backhaul all that traffic to a centralized data center, but rather when you've got users that are traveling across the globe, they can connect automatically using GYP technology to their nearest data center, and that way, nearest Zscaler data center. And the benefit of that is that, of course, they will get the best experience wherever they are, because ultimately we'll get that traffic again to the nearest Microsoft location, and it's Microsoft CDN that will take care of making sure that the content for that end user is served across their CDN. And we provide a full suite of security controls around everything that we do when it comes to the normal internet traffic. Of course, when it comes to the Office 365 suite, it's around optimizing that traffic to get to Microsoft. And we'll talk a little bit more about the simplified policy management in a moment. So just to drill down a little bit then about connectivity models, because I know a few of you may be interested about, well, actually, can you understand a little bit more about how this works? So the way that ultimately that applies is if we think, first of all, in a large location, then typically what we will see is a GRE tunnel towards the Zscaler node or point of presence that's closest to your location. Of course, that can apply equally at the satellite offices too. So that way you always have that direct internet connectivity. Zscaler also provides an outbound next generation firewall capability. One of the key points to note about this is that that means that you can take care of all of your outbound traffic, whether it be web traffic or whether it be your kind of non-web protocols. All of that outbound connectivity can be managed by the Zscaler next generation firewall. And the benefit there is that you can actually reduce your attack surface on your branch significantly, because ultimately if you're not hosting anything in that branch, then actually your point of control and in terms of your security posture is very, very simple, because basically all you need to do is allow effectively that tunnel out to Zscaler and obviously any other kind of standard NTP protocols, for example, you might require in from the internet. But there should be no requirement for accepting any ingress connectivity, therefore making that attack surface very, very small. Now, once you've connected, at that point you can send all ports and protocols across, whether it be TCP or UDP, to Zscaler, and will then route that traffic to its appropriate source. As we mentioned, of course, when you're out of the office on your laptop, you can either use a proxy auto configuration file, which many of you might be familiar with. That could be distributed through group policy, or alternatively, one of the things we do recommend today is actually to deploy, for example, a Zscaler application. The benefit of that is it takes care of a lot of the applications that might not necessarily be proxy auto configuration file aware, as well as providing some additional benefits around, for example, enforcement policies, so that you can make sure that users cannot uninstall it. And secondly, you can make sure, for example, that it can handle situations such as captive portals and other things. So from that perspective, we have a broad set of capabilities you can deploy to your mobile platform. And again, that will allow your users to get the best possible experience, because they will always go to the nearest Zscaler data center, irrespective of wherever they happen to be in the world. And that means they can always get to their enterprise applications as quickly as possible, as well as the internet securely, with all of the same security posture they would get if they were back in the headquarters. As we do all of this, we also make sure that we integrate with your standard authentication models, whether that be Azure Active Directory, whether it be Active Directory Federation Services, Okta, Ping, or other third-party identity providers, or whether you're using Kerberos, for example. Again, a number of different mechanisms we can use to authenticate the users to the service. And as part of that, we can then obviously monitor and report on everything that end users do on the internet. And as, of course, part of that will also bring analytics to help make sure that you understand how your applications are performing, how the bandwidth is being consumed and used, and what people are actually doing with that resource. So our intent is to make sure we provide the best of both worlds, whether it be the online browser-based experience, whether it be native client experience. We do support across all ports and protocols as we mentioned. So for example, if you're using the native Outlook client, That's doing MAPI and RPC calls over HTTPS. If you're using Skype for Business, then there is the signaling protocols that will go over HTTPS, but of course then you have the media plane protocols that will use, for example, UDP, and that introduces some problems actually for traditional proxies and firewalls, but of course for Zscaler we are a full-blown next-gen firewall capability, so we can handle those kind of media streams, etc. So that way we can make sure you always get the best possible media experience as well. And we talked a little bit before about the Office 365 one-click configuration to handle the exclusions and URL IP mappings. And I just wanted to come back to this point because it is actually quite an important factor in terms of the operational burden and impact of adopting Office 365. So let's say you've gone down the route, you've deployed all your infrastructure, you've gone down the Office 365 path. But one of the challenges is, if you, again, as we mentioned, is managing and keeping up to date with all those URL and IP address changes. So one of the things at Zscaler we have done is we've built effectively this object. It's effectively a switch in our user interface that allows you to effectively set that you are using Office 365 as an enterprise. And at that point, what we will do is we will monitor and work with Microsoft effectively to be aware of all of the URL changes, etc., that are occurring as they introduce new features and new capabilities. I mean, some of you may have seen the Microsoft Teams feature and Groups feature just recently added. Again, there was a significant number of changes there that were incurred that anybody who was trying to manage that through a traditional firewall would have had to then update their policies and push those policies out to those devices. For customers who are using Zscaler, because they're sending all of their traffic through the Zscaler platform on its journey to Microsoft, we actually accommodated those changes. And of course, because they'd used this feature, it removed that burden of having to track that configuration from the operations team. And again, that's a big help for many of our customers who are utilizing the service. So we talked a little bit about performance, but I wanted to just come back to this because I wanted to share with you a little bit of evidence about why this is the case. So the first way that we've helped address some of the performance concerns is through our peering strategy. And there it's around making sure that we are as close as possible to getting the traffic to Microsoft in the least possible time. So in that way, as we mentioned, typically our average kind of router-to-router latency is around 1 millisecond. If we think about it, that makes sure that we get the traffic as quickly as possible to Microsoft's front door and then allow their CDN to handle that in the back end. We've talked a little bit today about our scalable cloud access controls, particularly when it comes to dealing with those long-lived TCP sessions from each client and each user that you have within your enterprise. Again, because that traffic has been sent across a GRE tunnel, ideally, based on our best practice architectural recommendations, that traffic is actually not hitting your session state tables on your branch appliances or in your headquarter firewalls. And the benefit there means that you're not putting that burden onto those middleware boxes. Thirdly, we have built our own TCP IP stack. It's a little bit more of a technical detail, but one of the things that will help you maybe understand is why actually Zscaler can actually offer a better performance in terms of connectivity to Microsoft than you can get even if you were just plugging directly into your local ISP and connecting directly to Microsoft themselves. And lastly, we've mentioned around some of the DNS optimization to reduce some of the hop count. So Zscaler itself has many data centers around the world, including our service providers and others. We have some in the region of about 100 data centers across 5 different continents. We do deal with generally about 30 billion requests a day, and we see some in the region of about 125 million threats actually blocked each day for the general internet traffic we see. But rather than dwell too much on the security side, I wanted to emphasize the peering relationship on this map, and basically all of the cities shown in red, these are locations where we actually peer directly with Microsoft. So as you can see, there's around 20 different locations across the globe and major hub cities across the world that we actually are peering directly with Microsoft. So if you can get your traffic quickly to Zscaler, then we can get that traffic quickly to Microsoft. Now, the idea here is really to make sure that we have and we follow and we continue to expand our global footprint of data centers to make sure that we help with that peering strategy. And ultimately, if we work with our service provider partners such as BT, Orange Business Services, Verizon, Vodafone, AT&T, etc., we can help make sure that we give the most optimal peering strategy to make sure you get your traffic as quickly as possible, in effect, giving you an ExpressRoute-like experience without having to go to the burden or hassle of deploying ExpressRoute itself. Now, to give you an idea, again, in terms of scale, we did mention that briefly. We talked a little bit about the transaction levels. If we look at Microsoft Office 365 traffic, though, in its own right, we've seen an explosive growth. I mean, we see somewhere in the region of around 1 billion transactions, as you can see, daily on our cloud. And this is actually looking across some recent stats. But I wanted to just go through what a transaction actually looks like when you actually connect to the Zscaler platform, or if you connect directly to Microsoft. So without Zscaler, one of the things you can see, if you take your browser and you connect directly to Microsoft itself, one of the things that will happen is that your TCP IP stack will actually begin to negotiate the window size actually with the node that it's connected to. And you'll see that it starts at 256 bytes typically, and then ultimately what it'll do is it'll begin to scale up over time. Now, with Zscaler, one of the things we've done, because we've written our own TCP IP stack, is we've optimized the way that we actually connect to upstream services. So first of all, we designed it in mind whereby we're peering directly with software as a service partners. So we know we're on, for example, 10 gigabit links. We know we're on very low latency links because, again, we're paired at the major internet exchange peering points. But also because we've got a lot of long-lived connections to Microsoft, it means immediately what we can do is take advantage of a pre-negotiated large window size of 64 kilobytes. But also because we've optimized our stack, we can actually accelerate the window scaling functionality so that we can actually increase that window size. So in practice, what this actually means is if you're transferring, for example, larger files, say on SharePoint, it means we can deliver that content more quickly, more efficiently, more optimally down to your end device. And ultimately what that helps is to reduce the overall impact of latency on the end users. It means we can take advantage of the low-cost, high-speed bandwidth that often you will have to the internet today. And the idea really is to make sure that we give the best possible experience to end users when they download that traffic. Now, to give some third-party validation of this point, we actually engaged a third-party called Catchpoint who helped do some tests around the performance claims that Zscaler were actually making when it came to connecting our users to the Microsoft cloud. So they did a couple of things. First of all, they did some file download tests, but also they measured a couple of different metrics. Particularly it was around things like name resolution time and TCP connection and file download time. So to give you an example, this is with and without Zscaler in the mix. So if you think about it, this is an end user connecting directly to the internet, directly to Microsoft over their ISP, versus connecting over the internet to Zscaler and then Zscaler connecting to Microsoft themselves. Now, if we think about those numbers, actually, it actually proved over a 3-day window, whereby we were basically repeating this test every 15 minutes over that 3-day window, what we actually saw was a 40% faster download speed on average by going through Zscaler versus going direct. And again, this isn't any form of magic or secret, but rather it is utilizing the benefits and value that we get from having an optimized TCP IP stack, of course, in our own software platform that we have in our cloud. And we mentioned earlier on about name resolution. That's a big factor, and as we mentioned, typically the name resolution time that we have was occurring, or actually lookup time is actually within a millisecond. The average DNS resolution time for Zscaler across the platform was 20 milliseconds versus 170 milliseconds going direct. Ultimately, an 8 times increase in performance over what you might typically achieve. We actually will come back and share the link to the report so you can get more insight as to those claims that we're making. But in the interest of time, I mean, obviously we've looked so far about some performance capabilities. We've talked a little bit about architectural topology. Again, just wanted to highlight a couple of last points. One is around application visibility and control. So the fact that we can see, for example, all of the ports and protocols that are being consumed by end users. We can then pick out and identify what traffic belongs to Office 365, and we can provide you a lot of insight and metrics as to what's actually happening with regards to your Office 365 traffic. So we can see, for example, are there particular offices that maybe are challenged with regards to their bandwidth consumption? and maybe Office 365 is not delivering them a great experience, and maybe there needs to be bandwidth controls put in place. Maybe there are particular users that are heavy consumers of OneDrive, and that way that you can still identify why that might be the case. Or it might be the fact that you have a shadow IT problem. And again, we talked about in the previous webinar about how we can identify and discover applications such as Dropbox and Box, etc., that might be getting used for hosting intellectual proprietary content. So we build up the picture, though. It isn't just about those specific transactions that are occurring at the web level, but also drilling down into the detail when it goes beyond just the 18443 traffic. In this case, what we can do is actually drill down into the logging information to show you, for example, which users perform which transaction, and again, you can show all of this detail at a very low level. Now, one of the things we did mention earlier, and I think it maybe would be remiss of me if I didn't mention, was the fact that because we are sharing the internet as a transport, we now have potential competing demands for that resource. You will have, for example, your general internet browsing traffic competing for the demands for your enterprise application suite with Office 365. So one of the things we have done is provided the bandwidth control that we mentioned earlier. So just to give you an example of how this works, what you can do is you can define Office 365 as an application. It's actually a predefined application that you can select from our platform. And you can then actually say, I want to give a guaranteed level of bandwidth that I have available to the Office 365 suite. So when there is congestion on that link, what will happen is you will always get a guaranteed level of bandwidth for your enterprise connectivity, and then the remaining bandwidth will be available for other uses, such as video conferencing, such as streaming media, etc. And of course, the opposite can be true. You can put, for example, bandwidth caps in place. And indeed, we did have one customer, again, a human resources firm in this case, who used this feature to help make sure they could manage the bandwidth contention they had, particularly in some of their branch offices where they had a lower bandwidth available. In this case, what they did is they actually capped things like YouTube at a particular bandwidth level, and therefore making sure then that the remaining bandwidth that was available could be consumed by the Office suite. And again, you can break this down into a more granular level if required. So, I mean, in the interest of time, what I'm going to do is just kind of wrap up and then just give you an opportunity to ask a few questions before we close today's webinar. But a couple of resources I wanted to share with you. First of all, we will share this content, is the white paper that we mentioned, which provides some of the test results provided by an independent third party called Catchpoint about the connectivity options for Office 365 and their experience when they tested direct connectivity versus going through Zscaler, as well as our Office 365 deployment guidelines. And again, helpful resource to help you understand how Zscaler can help you on your journey to accepting and adopting the Microsoft Office 365 suite. So we talked about at the very beginning, and just to kind of close, there were 60 key kind of points that we wanted to talk about today about successful adoption of Office 365. It is all about the end user experience, and that's really predicated on a number of key points. The first is around network architecture, moving to that direct local internet connection as recommended by Microsoft, but avoiding the dependency on those middleware boxes. Using things like local DNS resolution and local access, again, Zscaler can help with that by our global points of presence across the world. Making sure that we manage that latency by obviously having great peering relationships with our ISPs and with Microsoft themselves. Focusing on both the browser-based and the native client experience, so making sure we can accommodate all ports and protocols, making sure that we can help deliver that in a way that works not only for users that are on-prem, but also for users that happen to be out on the road. And then considering some of the policy implications, making sure that, for example, you can take advantage of things like the one-click deployment capabilities so that when users are accessing the Office suite, they're not impacted by, for example, missing URLs that might not be in the firewall or missing IP address ranges that might not be configured on the proxy. All of that stuff is taken care of through the one-click deployment option. And then, of course, we talked a little bit towards the end around bandwidth controls to make sure we prioritize the business applications over maybe general surfing, and of course providing the visibility and reporting controls. So I think we might have run just a few minutes over, so my sincerest apologies for that, but I do have a couple of minutes if maybe there are a few questions, and maybe Shona, if I could bring you back online, that would be helpful, and maybe ask were there any questions, or maybe you can open the lines for any Q&A.
Okay, yeah, so I do have one question that's come through already. Thank you very much for that. I just want to remind anyone who's still on the line to pop your questions onto the question box. I will ask them to Andy and we'll address them one by one. And anything we can't address on this session, we can pass over to your account managers to discuss in more detail with you as well. So the first question I have for Andy, firstly, thanks for an excellent webinar, the delegate said. His question was, aside of Office 365, is Zscaler a cloud-based next-gen firewall that could possibly replace something like Sophos UTM appliance? I.e., does it offer proxy, NSA, VPN security, website allow block, etc., etc.?
So I'll try and answer that question as concisely as I can in the interest of time. So we are an outbound firewall. So from that perspective, we're really there to protect end users and their devices, irrespective of what application port or protocol they're using. So it is a genuine next generation firewall. So what we do is we will look at not only the 5 tuple, so we'll look at the source port, destination port, source IP, destination IP, and protocol type, but also we have a deep packet inspection engine that will identify, for example, what type of application content that might be there. So things like port obfuscation or application obfuscation techniques will not work. We'll pick those up and we'll identify those applications accurately. But of course, that works for outbound connectivity. Just to be clear, what we don't do is we don't sit in front of, for example, your server farm. So we don't sit in front of your web servers that are open to the internet. So we're really about providing that client-side protection versus server-side protection. Now, with regards to other features, we have our private access technology, which completely replaces the legacy VPN concept. Maybe that's a topic for another day. And of course, we haven't really touched upon all of the advanced threat protection that we provide. Again, I would maybe refer the person that asked the question, maybe to check out the webinar we did a few weeks ago, where we covered a lot more of that in detail. But hopefully that answers that question, and maybe if there's another one, I'm happy to do it now. Okay,
so I have a secondary question around IP address restrictions. So the customer question uses IP address restrictions to access Salesforce and other cloud apps. Does Zscaler now support this?
So I think the question here is related to source IP-based restrictions. So being a cloud platform, the address translation function actually happens within our cloud. So if you might imagine day in the life of a packet, you open up your session, it comes from a source IP address that's maybe an RFC19 address. It comes across a tunnel, for instance, arrives at Zscaler. What we do is we provide the address translation, and ultimately it will reach Salesforce with an IP address that comes from a Zscaler address range. So from that perspective, applications like Salesforce, etc., absolutely many of our customers use that successfully through the Zscaler platform. However, we are aware that there are specific scenarios whereby there might be a requirement to come from an IP address that belongs to the organization from whom the traffic was originally sourced. Now in that case, there are a couple of things we can do. The first is actually when we actually send any request to any upstream website, we actually include in the X-forwarded-for header the origin source IP of the tunnel, if it's a tunnel, or from the original source of the request. Now the reason for that is it allows identification of where the traffic came from, and indeed that can be used for geo-IP localization, etc., so that it makes sure that people don't use the service for masquerading their behavior. And indeed that's helpful, maybe in some regards, unhelpful that you can't then use, for example, Zscaler to go and access Netflix content in a different region because you want to watch different movies, etc. Now, many websites, they might support that, but we are also aware that there are some websites that still rely on native IP source-based authentication. Now, typically then, there are a couple of mechanisms that are available. One is you could provision and provide upstream the dedicated nodes from which you're coming from. So again, you can restrict that pool of IP addresses to just the Zscaler nodes. Of course, we have authenticated all the users go through our service. We have an audit log, but of course, typically there's further authentication done in that platform. So that is often acceptable for most users. In the most extreme cases, some people actually do exclusions. proxy or configuration files will allow you to potentially even bypass the service just for maybe that one specific application that requires that connectivity. We also do have, for larger organizations where it's appropriate, the ability to also extend our cloud into an organization's network. It's only really applicable to the very largest organizations, but then what that will allow you to do is effectively always come from one of an IP addresses you own. So there are a number of different answers to that particular problem. Often if we sit down and figure out what the application is, we can usually just find an answer that will hopefully address that requirement. But yeah, there are a number of different ways we can potentially solve that for the person that was asking.
Thank you very much, Andy. I hope that answered your question there. So I don't have any further questions. So all that it remains for me to do is to thank everyone very much for their time. I just reiterate that we have recorded today's session, so we will make that link available to the recording and also Andy's slides available to you by the end of the day, so you can review that and share that internally with your teams. Thanks very much to Andy for his really good detailed presentation, really insightful look at how you can deploy Office 365 in a different way. And also thanks to everyone who took their time to do Zscaler, and I do appreciate that people have very busy diaries, and we do appreciate when you do take the time to dial into these sessions. Thanks very much, and thanks for joining us this morning.